Welcome to this inaugural episode of the APL Notation as a Tool of Thought podcast, recorded on the 6th of October 2022. I'm Adam, and I'm here with my co-host Richard.
Hello.
And today we are discussing a tweet by Jeremy Howard, who mentions that there's some indexing notation in the Yorick programming language that he thought would be nice to have in APL. And so we're going to discuss merits of that and any thoughts that come up with that.
Just googled Yorick, but it's a League of Legends champion. Apparently, and League of Legends is much more popular than the interpreted programming language, designed for numerics, graph plotting, and steering large scientific simulation codes. Says Wikipedia. It is quite fast due to array syntax. Citation needed. It doesn't say that, but probably should say so. And I know the Wikipedia article for it introduces what we're going to talk about quite nicely, because it says features and it just says stuff about indexing.
So it's like an indexing programming language?
Apparently. No, well, I don't know, because we haven't actually tried it. But Yorick is good at manipulating elements in n-dimensional arrays conveniently with its powerful syntax. So
sounds like APL. But
it has indexing using arrays. Well, we have that. It's got a colon for like a range of.
Hold on, does indices. It have? Wait. Does it have indexing using arrays? X is an array. Right, so X is an array of the numbers from 1 through 6, and then
right.
Then it has some slicing syntax. So it uses apparently round parentheses for indexing. So X open paren 3:6 close paren means the inclusive
but
range.
It looks like, you can see below then. Sorry, you can continue. I mean, we never established this, but we could just stick this as a video as well.
Yeah. Of course, we're going to do that as well. But I'm just taking care to describe it for the listener that isn't watching. So it can do 3:6 means the inclusive range of elements from position 3 to position 6. It's apparently one indexed, like other mathematical programming languages tend to be.
That's true, yeah.
And then you can do 3:6:2, which means from 3 to 6 inclusive with the steps of 2.
Yeah.
And then you can do negative step size, and they will go backwards instead, stepping over it. But I don't see anywhere where.
But below it says arbitrary elements, and then I see X round paren, then square bracket 2:1 square bracket.
So that takes.
It looks like.
This would be like 2:1 semicolon 1:2 in APL, I suppose. So this is saying.
Yes. Yeah.
This is saying column 2 and then column 1, and row 1, row 2. So that's 3.
What do we get back?
Yeah, that's 2:1 5:4 in APL. It would be a 2:3 reshape iota 6. So that's 1 2 3, and the next row is 4 5 6, and then we're taking the second and the first rows, the first and the second columns of that. So that's exactly like APL so far, just with lots of more brackets.
Yeah. And then what's this? Pseudo indexing. Oh, that's right. This is the real meat of where we're gonna get to. Is this stuff about broadcasting? Is what it's called in NumPy, but it's basically just implied shape information. You don't have to explicitly specify everything you're trying to obtain from an array, because that would be.
But what's up with this dash? What's that? Why is 2 3 a reshape iota 6, and then why open paren minus, or dash, I suppose we should say, dash comma close paren. So that's adding a trailing dimension.
It does seem to be, doesn't it?
Because that would be like comma rank 0 in the APL.
Yeah.
So Rebel rank 0. Or if we had a promote function.
Oh yeah, because so they've called it threading in double quotes here, but that smells like what do we
That's
refer
just
to it
the
as?
that's
Zip.
just the auto mapping or the
It's a bit like zip. In the case of at least this 2-3 reshape 111000.
is that a division?
Oh no, wait, sorry, where's Y? Oh no, I'm not sure what the hell that is.
Okay, so hold on. So x open paren comma dash close paren. That gives us the
That's like a mix. Yeah, should have investigated this more.
well, okay, no. So no,
Before
okay. So if you put the dash before the comma, okay, I see what this is doing. No, it's very clear. So this is exactly this promote type thing. We're
Yes.
inserting a new axis. So normally x is a one-dimensional array, and that means it can only take a single set of indices in that single dimension. But if
Yeah.
you give it multiple, and then use a dash as a placeholder, that means add a new axis here. So if
Oh, so
you
essentially omitting one of the specifications, which says give me all of those,
actually it's the opposite because look, the
and then on
dash
the
goes
other side we're doing.
first. Uh,
Yeah, no, but I think the fact that there's nothing on the so we've got a comma, dash on one side, nothing on the other side.
yeah, so
I think the
dash means
nothing.
everything apparently, no matter how many dimensions it is on the left. And then nothing on the right means add a new dimension over there. And then if you put the dash at the end, it means all the trailing dimensions, but add a new dimension on the left.
Yeah,
So
something
the
sounds
dash
about right.
represents everything. That's all the indices along all the dimensions. And now we can divide by y, where y is a two-dimensional array, and we have added a dimension. So x open paren comma dash close paren is a 1-3 reshape iota 3. And the y
Yep,
is
right.
a 2-3 reshape iota 3. So then we need to match up the rows of
So that's one. So that's
the
that's
extended X.
yeah. There's several concepts going on in these examples all at once, but that last one is leading access agreement, right? But
It's not really leading
because you got a
access
one,
agreement.
because you got a
It's
1-3.
because they don't agree, right?
Oh, sorry. But it's like
It's
a
auto mapping. It's saying if the
yes.
dimension is length 1, then we will extend it to match any number, which is a bit
Yeah,
more than just leading agreement. It's more like a scalar extension type
yeah.
thing,
Scalar extension
but
for
a one element.
arbitrary major
It's one
cells.
element extension, really.
One major cell extension.
Yeah, which nobody has proposed for APL. It's kind of there in some APLs that we allow one element vectors to be treated like scalars that map. But
Yeah,
and I think I can remember John Scholes mentioning something about length 1 axis that we could allow those to map automatically.
yeah. I
It was
think. I
basically
mean, from the
booed
other
out.
comments, it feels like. Don't want to put words in his mouth, but it feels like
So I guess you could do
Roger
that.
wasn't that keen on
That's
those
not a
ideas.
syntax as much as it's a just an extension uh, of the conformability rules.
Yes, because we currently have that, like you say, with singletons, which could be a scalar, a one element vector, a one element matrix, a one element anything actually in
Yeah,
dialog APL, and that will extend, that will map across to other
but it
arrays.
only works for singletons. It doesn't work
Exactly.
for
Or one
length
row vector,
1.
one row matrix.
Right, that
Or...
it doesn't work for. And all
There's a
this
fair
is
question, isn't it? What
just
about a one row matrix versus a one
yeah.
column matrix? Should they
They can't.
agree or not?
Well, only if it all the
If you're being really loose with it.
yeah yeah. So all of this can be accomplished with rank, obviously. So in
Yeah.
this case, you could use rank -1, so that just matches up the matrix cells, which are the rows of the matrices, and you will loop over it like that. I mean, I guess this is kind of neat. On the other hand, I kind of prefer to specify what exactly I'm getting at because this is lots of errors probably could be avoided
I
like
think
this.
that's what's hard to say about this, especially given the like limited information we're coming in with, and the fact that it's all focused on some specific syntax around indexing arrays and matching up subarrays.
Well, it's two different things, right? One is the notation here for adding an axis, leading and trailing axis.
Yeah.
Um, I don't know how it would do it to add an intermediary axis. It doesn't say
And
here.
we have, you can do that with bracket axis in APL in lots of situations.
Adding an axis?
Yeah.
You can
Or
ravel. I mean, yeah,
catenating, whatever.
yeah. It was catenating, sure. But what if I just want to add an in?
Oh, yeah, we don't have the
And
promote thing like you say, but
no, so it might be an idea to have a function that that can add an axis arbitrarily. But I mean, you can do it. You can.
well, exactly. I think this is the running thread here is you can the extent to which Jeremy Howard is claiming that it's like awkward to do these things in APL versus what we're trying to figure out is it actually awkward to do these things in APL?
Currently, you can insert an axis by raveling with a fractional axis, and you insert it at that position, which means you can parameterize this. Is that a word?
You can
So
what?
in this, yeah,
Parameterize.
so Yorick has a notation for inserting a new axis between existing axes. But what if I want to write some code that adds an axis at a certain point? I don't see how I can do that other than like metaprogramming, constructing an expression. Whereas in the APL, currently what we have is the bracket axis on Ravel. So
Yeah.
let's say you have an array like 2, 3 reshaped by Iota 6, right?
Yeah.
And then turn on boxing to max so we can see what's going on. Okay, and now you can do comma open bracket 0.5, yeah, on that. Okay, and then you do 1.5. So this added a leading axis.
Yeah, an axis before the first one,
Yeah,
and here an axis after the first one, which is what the decimal notation
that's
means.
between the two. And then
Oh, between the
2.5,
two, sorry.
right? Yeah, that is for after the first one. And
Yeah,
then this adds
2.5
a
after.
trailing axis. So the first example here would be Yorick's comma dash, and the
Yeah.
middle and the last one is dash comma.
So comma dash is insert
That's
before,
insert in the front. So that's comma 0.5. Yeah.
and then dash
And that
comma.
one is
Oh,
the last one.
it's 2.5.
Well, in this case it is.
Yeah, yeah. It
But
depends
you
on
would
how
have to
many
make it
dimensions you
depending
have.
on the rank. On the other hand, the last one, you can write it as comma rank
I mean, yeah, you can
rank
do
0.
0.5 plus rank
Like that, yeah.
array if you want.
Or just use the rank operator. Just comma rank 0 will do it.
Wrong. Well, last one, right?
Yes. Adding a trailing axis, yeah. Right? But this also allows you, APL's with notation, I mean, it's a function application, allows you to insert it anywhere you want very
For
easily.
I mean, the bracket axis in this case is kind of the more convenient notation for doing that, because if you do
Yeah, I
it with
would say
rank, you
so.
need to rearrange the axes yourself, which is discussed in more detail in some webinars.
Yeah, the promote function
So
would be good, but that's not so much the syntax. So that's one thing. But I think what Jeremy was getting at was more the broadcasting than this notation. And here I'm a bit,
yeah, this is to do with not. So broadcast in this case is like matching. It is matching up subarrays from two arrays of different ranks, but without having to worry as much about what those ranks are.
I think
Like
so.
if you can fill in a lot of gaps. In NumPy et al, an example of the value of broadcasting is no special outer product operation is needed. We'll come back to that based on this Python discussion that he's linked to as well. But A none times B colon comma none. Is this some more insertion of... should I get NumPy out and try this? Let's not try and kill something that's running. I don't know how much you have to do to actually get to the point that you can do this. Okay, we have it. And then how do you make... Oh yeah, A is a np dot array.
And then you have to like a list of lists or something. Yeah.
So we're gonna try. I have no idea if this is gonna work because
I
I
think
don't
so.
actually know NumPy. To get Rodrigo in here.
Should have him on as a guest.
Uh,
That's useful.
well, like I say, I literally don't. You can oh, there we go. It's a lowercase array. Makes sense. And B is like a higher rank one, but with some type of conformity. This is 2 major cells, so it still needs to be 2 major cells. I mean, maybe we get away with a vector.
Well, he wants to do the outer product. So yeah, let's just do a vector for B.
Like, oh, it doesn't even need to be. Does that have to be the same?
No, it doesn't. For outer product, never matters what the shapes are.
So
get rid of the square brackets there. You have too many.
So we just got a single vector and a vector. Well, it's a.
So the result is going to be a rank 3 array.
Now, okay, good, right, okay. I'm doing the right thing here. I've made an array in NumPy that has a shape 2, 3, and another one that has a shape of 4. Okay.
Oh, that's interesting. The notation there for.
And then I have no idea if this is just going to work, where we just take a square bracket none asterisk b square bracket colon comma none. This I mean, so it does need some. It's not an outer product. So this is the first thing I think we took umbrage with when reading this feedback, was like the outer product is being described here, or is the term outer product is being used, but we're not convinced that what they're actually describing is an outer product.
Well, they're achieving an outer product, right? If you
in specific cases.
Yeah.
So in the case, like, okay, it's easier to demonstrate this in APL. The case where you do 2, 3 dot plus, or dot times neg1 not 1 maybe is the easiest to spot. Right.
So these are all the combinations, but what they're actually doing is they're letting the mapping take care of it.
Exactly. So they're doing a 2, 3 times rank 0, 1, neg1 not 1, which in this case happens to be.
Yeah, another way you can see what they're doing is if you enclose the 2, 3 and just do a multiplication. Okay.
Oops.
So
yeah, right.
That kind of thing. I mean, okay, so enclose the right side instead if you want.
Yeah, to get the shape similar.
Yeah. And now if you mix this,
then you get the same. But I'm trying to think of something where it's less obvious that the outer product is not the same as.
But no, but see, I think the point is you can get an outer product this way, but it requires that you manipulate the arguments rather than manipulating the function, right? So the APL approach is you apply an operator to the function so that you get the operation that you want. And here, what the example they're showing in the Yorick documentation or like description, that email thing on the Python list.
Yeah, let me get that up.
It seems that. Yeah, so here
this D plus E. Oh, I see. So
like, they start off with 1
convenient that they can just say plus.
Exactly.
And because they've already changed the arguments.
So the problem is that the E is this enclosed thing. So normally, in order for this to be an outer product, you start off with an array 1, 2, and we have the other, which is the proto E, and then you have D, which is 1, 2, 3, right?
Yeah.
And then in order to make the outer product happen, you have to add a trailing axis, right? So they would write the proto E, open paren, minus comma close paren. So that adds a trailing axis, and then you can use the normal, multiplication
plus
or
or
addition, so on
multiplication.
any operation that maps,
Yeah.
right? Like this. So that's really the difference here, right? APL uses notation for modifying the functions because of APL's notation for that's so convenient with operators that they can inline modify functions, any function.
Mm.
Then it doesn't really make sense to have this kind of functionality. You don't want to modify your arguments.
Well, I mean, when you early days,
So
you can
that's, you see,
kind of do
exactly,
this anyway, right?
that's what it says on here, right? If the above array E was 1, 2, then you could have added E along the columns using
B plus
this,
E
right?
paren
That's exactly what I was
dash
saying. Yeah,
comma. Yeah,
yeah.
exactly.
So I think this is actually it's kind of a patchwork for a lack of notation. And because they don't have a notation for outer product, then you need to lean on the broadcasting rules. And this probably will fail with any function that's not like a scalar function that knows how to do this. How do you do this with a general purpose function? You probably can't.
Yeah, I'm not sure.
I don't know if
Maybe.
I don't know if Yorick has inline like
Dot
infix
reshape something.
users. Yeah, well, we can do that in APL. We can do it with any function.
Just getting back to this one here, where my broadcasting failed. And that's literally just, I believe, this is to do with the shape being wrong. B is NP array 1, 2, 3.
Shapes 1, 2, 3. Actually, that's weird.
Why is the shape
A
of
A is not 1, 2, 3.
Well, maybe A none is.
Oh, so that so A none adds another dimension there, and then probably B none, B colon, comma none probably adds a trailing dimension or something. Okay, so this none thing is similar to what not what Yorick has.
And this is the promotion.
Yeah, that's a promotion thing. And
We're
then
calling
it tries to
rank,
broadcast.
rank promotion or demotion. So you can somehow insert axes changing the rank of an array. And then once you've matched up the dimensions using this mechanism, then the broadcasting rules take over, and then you can get the behavior you want.
Okay, so
whereas we would just do this with rank.
Well, if you wanted rank, but yeah, but you can also just in this case you just use outer product. But rank is much more general because you can choose which axis you want to pair up with which axis, whereas outer product just pairs up all axes everywhere. It makes all the combinations. But this is I disagree with Jeremy. He's saying this is a flexible, expressive, concise notation. Firstly, it's more verbose than the outer product. And it's not more as flexible as far as I can tell, but somebody might correct me.
Well, what are the two? Maybe it's about the same if you consider that we can pair one axis and apply a function between that single block of data and a whole series of axes in a higher rank array, or compare or you can match identical to identical, what are they called, frames. I'm talking about frames. So you can take a single frame and it will broadcast over a whole set of frames in another array, or you can take two that have matching frames and apply the function between those two. And that looks pretty much the same here, I think, in terms of the broadcasting rules. As long as you, but we're saying the main difference is the mechanism. We're applying an operator to a function that achieves this, whereas they're manipulating the shape to achieve this. My main disagreement is to say that, yeah, in any respect, this notation is more flexible, expressive, or concise. That's just, I don't agree with that at all.
Neither of the three, is what I would say.
and it's literally just a difference in like conceptually how you're achieving the goal.
Well, you
And
can
even
do
then,
this, right? You can do exactly this with
you can,
that
yeah,
we
you
have
just use
in.
reshape and or
Well, you don't even need to use
umpteen
shape.
functions.
If we did the thing with the enclose, right? 1, 2, 3
Oh
times
yeah, that
enclose.
too.
So that's basically like this. Enclose adds another layer. It's like adding another dimension.
And this is a very common, it's what people do, isn't it? When you want to
Yeah.
take like some matrix of numbers and you want to times it by a single vector with the same number of columns, people will just split them and enclose the other one.
Yeah, but that we can. Yeah. And you can mix it back together again if you want. But the
Right.
rank is a better way to do this.
Well, yeah, it is now, and other APLs had that. So rank 1 is what we do.
Need multiplication, maybe.
Yeah, probably. No, just do something.
Yes, do some
Could we have an
random function.
arbitrary function that just applies any function?
You forgot the question mark now, but this works.
Yeah, well, it wouldn't have it wouldn't have been the same.
No, of course. Doesn't matter. Yeah, so you can do this, but this is a bit clunky to go back and forth like this.
Oh, with the splitting and the mixing, yeah. No,
Yeah.
rank is much cleaner, and rank I think is kind of more. I mean, and then you can do something. Yeah, so you can reshape, but I agree that's not really quite the same.
Here's a fun one. If we have the under operator, then you could write times under split.
Alpha.
Yeah. You need over. Hold on. It's alpha over omega, yeah. There you go. So now you can type 1, 2, 3
1, 2, 3
times under split. Because split on a on the
that is
vector
invertible.
encloses it.
Okay, but I think these ideas are cool. I think yeah, I mean maybe this is part of the appeal as well, is in APL we've got several ways you can approach this, several ways you can encode similar ideas, which eventually tends to lead to some convergence among the community. Like, or it's you can't. Sometimes you get the best of both worlds. In the interim, I find it a bit awkward, like this, where eventually people settle on a kind of canonical. This is how APLers would do it way. And sometimes you find it's actually really beneficial that you can express things in the similar things in different ways, because it might be more convenient in different scenarios. But in between, you do get this, which I feel maybe a little bit of a distraction compared to what we're seeing from the content here, which is like there's broadcasting rules. You have to change the shape to do this thing, and then that is how you do it, and that's how it is done. It's not like a whole discussion. About what things mean. So you can do similar things with each, but it's more clunky. We're arguing you can do similar things with rank, and it's about as clunky.
Well, but each only for general case, if you're using scalar functions, they have each built in, right? So you don't actually need each. And in the general case where you need each, I'm not so sure that NumPy or Yorick could actually do this.
Right. So give us we actually need each. So that's like 1, 2, 3, 4. We're going to yeah. I guess they have to be the same, don't they? But
I mean, a length 1 axis agreement that could be added to APL. I'm not sure if it's a
right.
good idea, but it could be.
Yeah, this is where my example doesn't quite sorry, I'm trying to unconflate the two ideas. One being this each where we're applying a function between like cells. We match up the cells on two arrays, and the fact that arguably the leading access agreement would work on top of this, right? So that A, B, C, D here didn't have to be a vector or something.
Well,
This is
I mean,
that's what I'm wondering
leading
in my
access
head.
agreement would only work if, well, the leading axis had the same shape,
Yeah, so
right?
this is
Same
like
length.
so.
You can do it. Try to do a bracket apple cart leading axis operator.
Oh, you got one now.
Yeah. Okay, so take that and yeah, call it like underscore LA or something, whatever. So now you can do iota 5 in
Plus
yeah
LA 5x3 reshape
10.
10.
Yeah, it doesn't matter.
Whatever it is.
Right? That I think we should add.
Where you don't have to put LA. Or you think we should be an explicit operator?
No, I think well we don't have to put LA. It would be fine.
So what was previously a rank error now works.
Something like that.
That's
Yeah, I
gonna
don't know
get
which it's a length error or
so
a rank
much
error.
pushback from the backwards or not backwards compatibility people, but the
This should error people.
this should people depend on these errors instead of explicitly testing the shapes.
So, but what they're really saying is, if you let's define a promote function. So promote is just mix a
apple cart, so mix
no
top
mix a
omega.
top ravel top enclose if you want.
Yeah.
Looks cute too. So call that P or something. Promote. Okay, so if you had a promote function, which I think should be like monadic and symbol. Then what they're saying is you should be able to write open paren promote, and then 1, 2, 3, and then times this 5, 3. Reach a bit, right? This doesn't work. It doesn't even work if you do leading access agreement.
Yeah.
You can try, but it doesn't.
Well, because promote this is just turning
because the leading axis is length 1. Right? Yeah, it adds a leading axis.
Hold on, is that the same example? I mean, if I manage to get the NumPy thing to, but I see.
Well, in Yorick it worked. I don't know if this works.
No. This is just because I've got the shapes of this thing wrong, right? It would work if
oh, it should have length 2. B should have length 2, so it matches.
Yeah, exactly, or something. Right. So
okay.
Now B : none. As if this is elegant.
Yeah.
Is has two things there, and A none has two.
No, but then why does that have an extra axis? I don't know why that needs axis. Can you just do?
Because A's big anyway. Like maybe A wasn't supposed to be this large.
Can you just do B : comma none times A?
Yeah, probably. Yeah.
Yeah, but this is not an outer product.
Well, that was what I was. That's what I was saying earlier.
That isn't an outer product. It's just a mapping, and it has the same result as an outer product. But that keeps bothering me.
That's why I'm trying to think of an example where they don't, which I know that there are.
No, hold on. No. You need to and I see.
You
You
said
need
the
to
one-
promote. You need to promote A as well because that's not an outer product, right? That's mapping 1 to the first row and 2
Yes,
to the second
exactly.
row.
That's a rank.
Okay, so now So can you do B times A open bracket none, whatever that thing is you had to write? Yeah.
Oh, if you want to promote A as well.
Yeah, none. Okay, so now and then do B times that. No. No, it can't because Python doesn't do or NumPy doesn't do this length 1 thing.
Might just be the wrong. Hold on, I'm going to backtrack a second and get clarity on what we're doing here. So we got A is this matrix, B is this vector. They both have 2. You can't just do A times B.
No. Oh, go into APL. We can do this in APL and see what's happening here, conceptually at least. Okay, so we've got A is 1 with this, yeah, and B is 1, 2. Well, actually, doesn't matter. 1, 2, 3 is fine as well, because now we are doing outer product. So let's just do 3.
Oh, okay, yeah, that's one
Okay.
big difference.
So now,
It's A jot tot plus B.
yeah, should
That's
give
a
all
real
of
outer
these.
product.
That's a real outer product. So, but let's do this without doing rank and without doing um outer product,
Mm.
only by using leading access agreement. Now you're saying, oh, leading access agreement doesn't work in APL, but we can do that using enclosures instead of, right?
Oh, because we're trying to map.
So leading access agreement exists in APL in the sense that not access, but leading depth agreement, if you want. So if you split A,
Yeah. Now we've got.
right? And we also split B, which does this. Then B is a scalar and A is a vector, which means they get paired up. So now you can do, that's exactly
Yeah.
what they did before, right? So you can do split of A times or plus if you want split of B, and then you got the outer product. We did that by adding x's.
Well, not the outer product. Well, I guess maybe what they were referring to it as. Well, this is what's confusing me is because their examples all just happen to be the same as an outer product for some particular
Yeah,
case, but I don't know what the general
but
broadcasting
that's
that they're raving
they're
about
adding
is.
x's until the broadcasting rules makes it an outer product. So if you
Or until it just because in this case, right, are we doing 1, 2, 3? This is not an outer product anymore. If we're just trying to add 1, 2, 3 to each row in A.
no, but what happens? So if you do open paren and split A close paren plus split B, that's an outer product, right?
Oh.
So the first split is just to convert from high
Okay.
rank to
Okay.
depth so that we get leading access. And then the additional split is adding the leading access to B.
So A is like this. B is now just going to be 1, 2, 3. I don't know if I need to make it an NP array or not, but okay. And then to do this equivalently, we're going to oh, we need to find out the opposite of split. No, we're going to promote B until it works.
Yeah.
Oh, but this is a different model.
Yes, you can't really.
Yeah, but I'm sure I can fudge it.
That's not what it.
No.
I mean, sure, if you want. We're also mixing around which one goes on the left, which
Well,
one
this
goes
is what
on
I'm
the
trying to
right.
figure out.
But I still don't think.
Yeah, is it
Ah,
this? No. Oh, that's the first thing I was talking about,
yeah,
which is just adding
this
one row to
is
another row.
yes, that's not right. We want to add another dimension to A as well, so that we get the outer product.
Will this do it? No, because
Yeah. Well,
huh?
no, that's the same thing.
Why is it the same thing? I've added another
It's
dimension. Oh, do I need to
because
add?
it just goes into it. Then you keep that outer dimension. You want the opposite dimension. You want it at the end. Yeah, something like that. Whatever that means.
Suspicious. Don't think this will work. But again, it's the same.
No,
It's
hold
not
on. Yeah, you're missing the comma colon on B.
on B.
Yeah, or comma. I don't think you need the colon, really.
No, one way or the other.
I don't know.
I don't know either.
Even.
Oh,
There you go.
hey, okay, okay. Well, I mean, this
Colon
is
comma.
yeah. We'll chalk the fudginess up to the fact I don't know NumPy, and I'm just stabbing until I
This not the right result though, is it?
figure out.
It's not because it's
Oh, sorry, I'm
transposed.
multiplying. I'm multiplying, whereas
Oh,
I've added
okay.
there.
So, yeah.
Hooray!
Yeah, you'll get the same result.
Um,
But I mean, intuitive.
well. I guess if you get used to it, you get used to it. But I am serious. Well, yeah, the whole point of why we decided to do this as a podcast is we were seriously questioning the claim that this is better or even significantly different was in my mind. Is this even significantly different to what's achievable using operators in APL? And we've demonstrated, like, yeah, it could be an outer product dot whatever. It could be just splitting until you do it. Use APL's broadcasting, which is the scalar extension, or mapping between same shape arrays to achieve a similar result, or or you use rank. Whichever way you do it, Whereas in NumPy they say actual, you could argue it's definitely more Python to say there's one way to do it, and that is we have these broadcasting rules, and you've got to mess with the shape until it works, until it does the thing you want, and you can do similar things. That's one thing. Yeah, maybe people will be convinced by that. I've gone against APL now. There should be one way to do it. I don't really believe that though.
Yeah.
And where we've hit the limit is definitely understanding what other things you could do here beyond just adding and multiplying two arrays of numbers.
Yeah, this would be
in APL. Our operators are general to the extent
Yeah.
you can use any function with them, and it does the thing. Here, I don't know what other functions I'm supposed to use because all the examples been thrown, and I'm not going to investigate that now.
Well, I must presume that these broadcasting rules in NumPy and Yorick do not apply to general functions that are not scalar in nature, because then how you would know what to map with what?
I don't know.
They have to just take the whole array. There's nothing you can do. Or they could take some drill down until they get something of the rank that they expect, like the function rank you have in J. But it's not. You definitely can't do a general purpose thing that maps. Like for example, let's say it was membership, for example. Even if you don't have the issue with membership that revels its argument like an APL. But for membership, you have to specify what you want to pair up with what. Right? Otherwise, you don't know what is it the whole thing, or is it each one of them you want to look if they're members, right? Or is it each one of them you want to look that are members? And in that case, broadcasting rules cannot work. You must be explicit about it. And then I'd rather have a general purpose system like the rank operator, even if in some cases it's a little bit clunky, you could say.
Yeah, in those cases where you got to
But leading access agreement would take away a lot of the trivial cases for rank. Make it does clear. And then it still leaves rank available for when you actually need something fancy. So
maybe that's the question. Might be more of a framing problem where how do you introduce this stuff? Right, if Jeremy's saying you can do similar things with each, but it's clunky, why is
you might be doing it wrong if you're trying to use each.
Why is that the case? That he believes he needs to use each.
Well, that would be in the general. Instead of using the rank operator, you could do the splitting thing or enclosing, and then you could use each for a general purpose function, not for a scalar function, of course.
I mean, maybe he's doing that. I don't know. Maybe
it doesn't show any examples of it.
Split A plus each. Maybe he's writing that and doesn't need to. I don't know.
Yeah, I've seen people do that.
Yeah, me too. Hard to say. Anyway,
I think we have an answer for Jeremy.
Yeah, I don't think we can go much further than this. There's one other thing, which is some syntax for indexing that omits middle axes. We already have some bit of this,
but not as a syntax, right? We don't have notation for this as well. We do kind of.
So you can omit trailing axes using squad.
Yes,
so that's kind of whatever. So you can just say I want. Yeah. Well, 1, 2. I guess the middle one. Give me.
To show what the whole array looks like. So this is 2, 3, 4 reshape the alphabet. So this is a 2-layer. Each layer has 3 rows and 4 columns of the letters from A to X. And then you're saying, I want along the first axis, I want the first layer, and the second axis, I want the second row, and then I don't want to index anymore. So then we get all the elements of that row.
Yeah.
And then if you
so that's equivalent to in here B 2 3 ... Oh, sorry, 1. Well, whatever I wrote. 1, 2, dot, dot, dot.
But if you want trailing axis instead, then you can use the rank operator.
Right. So then you say, I want the second of each thing,
Mm-hmm.
but
Yeah, for example, like that.
I don't care what the beginnings are.
Or
So,
this is actually a, yeah, this is the trailing one. Yeah.
so give me. It's gonna be annoying looking at the full one of this, but
Yeah. No, but this works, right? So this took away the trailing axis, collapsed it into just having that one being represented by its second element in the result. So that's fine.
so that's like a dot 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 2.
Mm-hmm.
And then what we're missing is this thing in the middle, or the last example. And I thought about this a little bit, and it seemed to me like you could only do this. You can say first and last, and then whatever's in the middle. You can't pick and choose arbitrary things to miss
No,
out.
so again, it's like, sure, for that case when you want that, then yeah, but not the general case. However, you actually can do that in APL. I just realized I don't like it, but you can. So you can do two indexings, yes.
Can index twice
But you can actually use the bracket axis operator. So you
with
can actually, so
squad.
let's just do 2, 3, 4 reshape quad A.
Yeah, yeah. Let's go back to
Yeah.
something simpler. Two,
So
three, four.
and show
Reshape quad A.
well,
If I can learn to type, typing's hard. All right. 2, 3,
okay.
4. Reshape
And
quad
now
A.
let's say that we want the first layer only
Mm-hmm.
and the third column. So that would be C, G, and K, right? But the problem is you want to skip the middle indexing.
Yeah.
So what do you? So you could put in all the indices in the middle. So you could put a parenthesis, and then it would be.
And in fact, you'd have to do this the other way round. Oh,
No, no,
right.
no, hold
So
on. So you
all the
could put in the
parentheses.
middle, right? You couldn't you do one and then so the middle index has three elements. So you can write one
One.
open paren iota 3 close paren 3 squad 2 3 4. Okay? So that gives
Yeah.
us that, right? So this is saying along the first axis, I only want the first layer. Along the
And then,
second axis, I want
yeah.
all three rows. Along
And
the
you'd
third,
awkwardly, in the general case, you'd awkwardly put
yeah, you would have to do. Okay,
whichever.
okay, hold on. But so here's a different way of doing it. Yeah,
So it's incredibly awkward if you're trying
yes,
to
that
generalize
is
that.
awkward.
In
But you
that
can actually
case,
write 1 3 squad,
but you can actually write 1 space 3
and then
squad.
open bracket.
Yeah.
One is a bit funny that it's the same number as for here. 1 3.
Oh, right. Oh, because I want the first. I
So
want
this is
these
saying,
indices from the
yeah,
first
they're
and
saying
third axes.
the first set of indices, which is just the scalar one, is along the axis 1, and the second one is along axis 3. So that's basically this, except ours is much more flexible.
This is
You
this
can
is
pick
more.
and
This is
choose.
exactly what I was saying. This is
Yeah,
more general. That it doesn't look like you can do in Yorick. So you can do
and
1
you
3.
can do multiple skips. So you can do
So
number
here
1, number
we're
3, number 5.
you know, I say I want the first and the last ones. This is like what Yorick would have as 1 dot 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 3.
Mm-hmm.
But we can actually choose any of them. So I can say the first and the third, even though there are 4 axes.
Yeah.
Well, there you go.
But and if you don't like this bracket axis thing here, you can do it with regular indexing as well. But there you have to know how many dimensions there are. Right. So you can just
Yes,
use the
yeah.
semicolons that make them empty means everything.
Oops.
So
Right.
J has an
So-
interesting thing. Yeah, so that's the same.
Oops. One more
There
axis.
aren't. Yeah, you have 5 here. There are only 4. You need to take one semicolon away. Yeah. And then
Also, and it was 1 3. I was squatting on those. There we
yeah,
go.
whatever.
No.
1 2 3.
I
Oh no,
was
no,
right
you're
the
4. No,
second
no, you
time.
changed it to 4 dimension. Yeah, okay.
Yeah.
Yeah, there you go.
All right, sorry. That was the first one I was trying to get, which is
Yeah.
the first and last.
Yeah. But
And
then you can do intermediary
and then
ones.
you can do intermediate ones. So I was doing the first and the third.
Yeah. And this I don't think you can do in Yorick. As far as I can tell.
Yeah, and the awkward thing with the square brackets is you have to know how many dimensions in advance and put semicolons. But the nice thing with squad with axis, which I
But
hadn't realized, is it's arbitrary. You still need to know the relative positions of the axes you want. I mean, at the end of the day, that's
So what would be
unavoidable
nice is
in any
if the
system.
square brackets could do negative numbers. So you could say I want the last one that would be negative
Mm.
bracket -1,
Well, you always just
right?
put the
But you can
whatever it
always,
is,
yeah,
put the
subtract it
rank and
from there.
subtract
Yeah.
whatever.
Yeah, actually, you could anything you want to be trailing, you can use rank for that. So you don't need to know how many there are.
Oh,
But then by using multiple indices, so let's say you wanted the third last one, that's the one here, and the last one, which is with 3. So then you know that you are indexing only into a trailing rank 3 array. So you can do 1, 3 here inside the brackets. You get rid of the whole yeah, the whole
defin,
defin
yeah.
thing, and then you just do rank 3
Rank. Yeah, right.
because you know that that's what you want, right? I think that's
That's
pretty
not so
flexible
bad.
too. No. So then, but
Not
then
so
you would need
bad.
multiple applications if you wanted some leading ones and some trailing ones, and
Mm.
you don't know what the
But whatever. Like
total rank is.
in the case that's equivalent to what we've seen in these messages,
Yeah,
that's actually not bad at all.
no.
Yeah, and I don't know. I'll be interested to see a response. This was actually much longer discussion of this than I
Yeah.
anticipated, but it's because we have fully fleshed out array models and we're array languages, so we think about this stuff a lot.
So J has the notation with its indexing function that if you do an additional layer of enclosure, then it means all but these elements. So if you enclose
Oh yes,
an empty list, then it means all but none of them, meaning all of them.
yeah, right.
So then you can skip dimensions like this, but still you need to know this exactly what you want to skip, how many there are. So, but let's count. How many times have you actually wanted to do indexing on an array where you want to index both leading and trailing x's, but not intermediary ones, and you don't know how many intermediary ones there are?
I
Seriously.
mean, so the answer for me, I think, is never.
Yeah.
But mainly, you know, but there's a chance that that's because in that case, I think I mentioned this to you when you brought this up to me. What was it, last week? Was recently I wrote something. I'm trying to remember exactly what it was. Whatever. It was something where I had 2 arrays of different ranks, and um, I wanted to pair up like rows of one and broadcast them across. I think it was scalars of another in the end, but I had initially framed it as either a couple of uses of rank plus transposing the argument in the end, and then when I went to rewrite it, it became a single use of rank and no transposes at all, or something like this. I can't remember the exact things. It doesn't make a lot of sense the way I'm describing it, to be honest.
No, but often if you need to do this kind of thing, that might be because you have structured your data wrong. And if you keep your access in a different order, you can get a saner manipulation
Right,
of
and
the
I also
data.
think that in that case, you're probably going to end up finding it more intuitive to think about the data you're doing if you rearrange it, because clearly you care about these things in the middle in some respect.
Yeah.
I mean, it's rare to use arrays of such dimensionality that you need this like anyway.
I mean,
Just in
it's
the
rare to use
general case.
dimensions more than 2,
Yeah,
right?
yeah.
Like 3, it happens. 4, that 4 is when you need an outer product between 2 matrices, and then you cut it down afterwards. But not knowing how many that access you have and still wanting to access subsets of them, it's
Right. The generality has like maybe 2 benefits. One is you're not having to care about it within the syntax. So you do, when you're programming, you do know that you have a rank 2 array or rank 3 array or whatever. But when you write the syntax, you want to not have to care about that as much. It's just a bit cleaner to do it that way. That's one benefit. And the other one, which is so rare that a question if it really happens at all that much, is that you're writing a function and you want it to be so general that you might be getting arrays of different rank and the same function applying to it. That's way rarer, I think, in terms of what you want than just the syntax being a bit cleaner, which I can see the desire for. I just don't I just think we have that. We clearly have
Yeah.
that. Maybe what we don't have is good, neat examples. We should do it. We should probably not this week, but in the next few weeks, make a notebook or something, a video that's a bit more concise, explaining these ideas in a way that people like Jeremy in the future are not going to be claiming that APL doesn't have this conciseness or neatness. Or I'm putting a lot of words in Jeremy's mouth as well. I feel when I'm describing this, it's just that if you tweet something out like it's a flexible, expressive, and concise notation, referring to a notation that's not APL, and atting dialogue APL, tweeting at us. The implication that I'm reading from this is that you're implying that we, in some way, don't have this. Actually, he does explicitly say you can do similar things in APL with each, but it's more clunky, in my opinion. But you don't have to use each, and then it becomes at least equally clunky, even if you don't believe that it's more or less clunky. Because I will admit that some of my clunkiness today with the NumPy and thinking about Yorick is just pure lack of familiarity, right? I'm not a NumPy programmer, I'm not a Yorick programmer, so obviously the APL way is more intuitive to me at the front end. But I think comparing them apples to apples are probably fairly similar. Apples to APL.
Yeah.
Apples to Pythons. Notation wise, I think they're about as good. And we might argue that APL is actually more flexible in terms of functionality, at least from what we've looked at and thought about today. Maybe someone can.
We might be a little bit biased, you and I.
Yeah, that's what I've been rambling about the last minute. Is we're a little bit biased, but I think hopefully we've talked it through, and I think it's APL's not worse. At least, is that fair?
Yeah, I think
we'll let the listeners and viewers decide.
Jeremy, you've got an answer. You gotta answer us back if you.
Yeah, that's right. Yep. But I do agree we need to make or I do think we need to make something that lays this out in some way that makes it clear. I mean, maybe it's just we'll ask Rodrigo and maybe throw it out to some more actual NumPy people. We make a thing that actually just compares them.
Yeah,
straight up. That's probably
sure.
Useful.
We can make a video for that.
Yeah.
Okay.
But yeah, I've run out of things to talk about.
That's good. Our hour is up. I'll talk to you.